Dear children, hearty welcome to today's class. Last class, we were discussing about viscosity. In this module, we are seeing the hydrogen bonding in water and consequences of hydrogen bonding. Let us see first what is hydrogen bonding. Hydrogen bond is a special type of dipole-dipole interaction between molecules. Hydrogen bond is a special type of dipole-dipole interaction between molecules. We have already seen that what is dipole-dipole interaction. That is the interaction between the two dipoles. So here hydrogen bond is when a hydrogen atom is attached covalently to a highly electronegative atoms like fluorine, nitrogen or oxygen, which it can have, the hydrogen atom can have the dipole-dipole interaction with another electronegative atom. This is the hydrogen bond. That is, when a hydrogen atom is covalently bonded to the electronegative atoms like fluorine, nitrogen or oxygen, it can have the dipole interaction. The hydrogen atom can have the dipole-dipole interaction with the other electronegative atom of the same substance or different substance. That is called it as hydrogen bond. I repeat, the hydrogen bond is when hydrogen atom is covalently attached to the electronegative atom of fluorine, nitrogen or oxygen. This hydrogen can have the interaction with the dipole-dipole interaction with the other electronegative atom of the same substance or different substance. That is called it as hydrogen bond. When we consider the example of hydrogen fluoride, here this hydrogen is attached to the fluorine atom. Since the fluorine is highly electronegative than hydrogen, this fluorine is having partial positive charge. This hydrogen is having partial positive charge and this fluorine is having partial negative charge. That means there is a charge separation or polarity between the hydrogen and the fluorine atoms in the hydrogen fluoride. So this is about the hydrogen bond, because since there is a charge separation between the hydrogen and fluorine in hydrogen fluoride, we can see that the molecule becomes polar. This hydrogen fluoride becomes polar, or we can say that hydrogen fluoride is polar. The hydrogen, which is the positive end of the molecule, interacts with the negative end of the neighboring molecule, forming a bridge between the two molecules. So as I said earlier, here we have a hydrogen fluoride. This hydrogen is having partial positive charge and this fluorine is having partial negative charge. This hydrogen is having an interaction with another electronegative atom of the same substance or different substance. This interaction is nothing but double dipole-dipole interaction, and this bond, this hydrogen and fluorine bond is covalent bond. So this interaction, this is called it as hydrogen bond. The interaction of the dipole-dipole interaction of the hydrogen atom with the electronegative atom of the same substance or different substance is called it as hydrogen bond. And this hydrogen bond is weaker than that of the covalent bond. Covalent bond is having the energy of about 150 to 450 kilojoule per mole, but our hydrogen bond is having the energy about 20 to 100 kilojoule per mole. And this hydrogen bond is stronger than our ordinary intermolecular forces. The strength of the intermolecular forces is less than that of 20 kilojoule per mole. This is less than that of the hydrogen bond. Hydrogen bond is having the energy of 20 to 100 kilojoule per mole. This is about the preliminary ideas of hydrogen bond. So hydrogen bond is nothing but the interaction of the hydrogen atom with the electronegative atom of the same substances or the different substances. Hydrogen bond is stronger than that of the intermolecular forces but weaker than that of the covalent bond. Now, come to the different types of hydrogen bonding. We have two types of hydrogen bonding. First one is intermolecular hydrogen bonding and second one is intramolecular hydrogen bonding. Intermolecular hydrogen bonding, as the name says, it is between two substances. Intermolecular hydrogen bonding between two molecules. Intermolecular hydrogen bonding is between two molecules. Intermolecular hydrogen bonding is between two molecules. That is the definition here. Hydrogen bonding present between different molecules of the same substance or different substance is called intermolecular hydrogen bonding. It is intermolecular hydrogen bonding. The interaction can be between the same substance or the molecule of the same substance or different substances. Then the intermolecular hydrogen bonding causes the association of molecules into clusters. Because of the intermolecular hydrogen bonding, the clusters can form. When we look into the example of hydrogen fluoride, here we have hydrogen, here we have fluorine. Hydrogen is having partial positive charge and this fluorine is having partial negative charge. And this hydrogen is having a dipole-dipole interaction with the fluorine of the other hydrogen fluoride. So this is intermolecular hydrogen bonding. That is between the molecule of the same substance, between the molecule of the same substance. Here in hydrogen fluoride, the hydrogen bond is between the molecule of the same substance. Here this hydrogen fluoride is forming an association. Here this hydrogen is having an attraction with this fluorine and this hydrogen is having an attraction with the fluorine of the another hydrogen fluoride and this hydrogen is having an attraction with the another fluorine of the hydrogen fluoride and this goes on. Okay. Then when we look into the intermolecular hydrogen bonding in another aspect, that is it can have with the other substance, molecule of the different substance. Hydrogen fluoride is the attraction with the same substance, molecule of the same substance. And here we have an example of ammonia and water. Here we have the interaction or the hydrogen bond between the molecule of the different substance. Here we have ammonia. N is having partial negative charge. Nitrogen is more electronegative. Therefore, this N is having partial negative charge and hydrogen is having partial positive charge. This hydrogen also has partial positive charge. This hydrogen also has partial positive charge. And when we look into the water, here this oxygen is more electronegative. Therefore, partial negative charge. Hydrogen is positive, partial positive, and this hydrogen also partial positive. When this ammonia and water molecules are come in contact, there will be an interaction between the hydrogen of this ammonia to the oxygen of water molecule. Therefore, there will be the formation of hydrogen bond. Same way here, this nitrogen is having an interaction with the hydrogen of the water molecule. Here also there will be a formation of hydrogen bond. Therefore, the intermolecular hydrogen bond formation can happen between the two molecules of the same substance or different substances. Now, let us see some of the examples of intermolecular hydrogen bonding. When we look into the hydrogen fluoride, hydrogen chloride, hydrogen bromide and hydrogen iodide, this hydrogen fluoride is having high boiling point. Its boiling point is about 19 degrees Celsius. This is due to the extensive network of hydrogen bonds between the hydrogen and fluorine. Once again, I repeat, the extensive network of hydrogen bonds between molecules, that is, greater hydrogen bonds in HF, leads to a higher boiling point than the other hydrogen halides. They are HCl, HBr, and HI, which are heavier but they are less electronegative. When we look into this chlorine, bromine, and iodine, they are less electronegative compared to fluorine. Therefore, this HCl and HBr and HI, the hydrogen bond formation is very weak compared to the hydrogen fluoride. Therefore, the boiling point of hydrogen fluoride is higher than that of HCl, HBr, and HI. Another thing which we have to remember here is that HF is liquid whereas HCl, HBr, and HI are gaseous at temperatures close to room temperature. This is also due to the hydrogen bonding of HF. HF remains as a liquid, but HCl, HBr, and HI are gaseous because of hydrogen bond formation in HF. Here we have the hydrogen bond formation of HF. Because of the hydrogen bond formation of HF, it is having high boiling point and it can remain as a liquid while other molecules in the series are gaseous. Another examples for intermolecular hydrogen bonding are between water and ammonia. They show extensive hydrogen bonding when they are come in contact. Next, we look into the other aspect, that is the effects of hydrogen bonding. The effects of hydrogen bonding. Because of the hydrogen bonding, group cysteine hydrates. In the group cysteine hydrates, the water is having high boiling point. Water is having high boiling point compared to H2S, H2SC, H2T. We know that in that series oxygen, sulfur, selenium, and tellurium is there. So when we look into this series, these hydrates, group cysteine hydrates, that is water. Water is having high boiling point compared with the H2S, H2SC, and H2TE. This is because of the hydrogen bonding of water. Then, when we look into group 15 hydrates, look into group 15 hydrates, they are ammonia, PH3, ASH3, SbH3. The ammonia is having high boiling point. Ammonia is having high boiling point compared to PH3, ASH3, SbH3. We know that in group 15 elements, nitrogen, phosphorus, arsenic, and antimony. So when it forms hydrates, the ammonia is having high boiling point because of the extensive hydrogen bonding in ammonia. Another effect is that the lower density of ice is compared to liquid water is also due to the extensive hydrogen bonding. When we look into the organic compounds like carboxylic acid, alcohols, amides, and amines, they can form hydrogen bonding, that is intermolecular hydrogen bonding. Because of that, these molecules are having higher melting and boiling points. The carboxylic acids, alcohols, amides, and amines are having high boiling and melting points because of the intermolecular hydrogen bonding. These are the effects of intermolecular hydrogen bonding. Intermolecular hydrogen bonding is the hydrogen bonding between the molecules of the same substances or different substances. here the different effects are in the case of group 16 hydrates, that is the water is having high boiling point compared to the hydrates of the other elements in the series. And if you look into group 15 hydrates, ammonia is having high boiling point compared to the other hydrates in the group. Then the density of ice is low because of the hydrogen bonding. When we look into the organic compounds like carboxylic acids, alcohols, amides and amines, they are having high boiling points and melting points because of the intermolecular hydrogen bonding. This is about intermolecular hydrogen bonding. Now let us look into the second type, that is intramolecular hydrogen bonding. That is intramolecular hydrogen bonding. As the name says, the intramolecular hydrogen bonding is the hydrogen bonding present within the same molecule. The hydrogen bonding present within the same molecule, that is called it as intramolecular hydrogen bonding. The hydrogen bonding present within the same molecule. The example for intramolecular hydrogen bonding is orthonitrophenol. Orthonitrophenol, here we have the structure of orthonitrophenol. Phenol is having nitro group at the ortho position, that is orthonitrophenol. This is phenol. This phenol is having nitro group at the ortho position, that is orthonitrophenol. Here this oxygen forms a hydrogen bond with the hydrogen of this hydroxyl group. This hydrogen bonding is intramolecular hydrogen bonding, the hydrogen bonding within the same molecule, that is called it as intramolecular hydrogen bonding. This is about the intramolecular hydrogen bonding. Now we saw that what is hydrogen bonding and the different types of hydrogen bonding. Now let us look into the hydrogen bonding in water. Because of the hydrogen bonding in water, it shows unusual properties. When we look into the water molecule, the structure of water molecule is like this, that is bent structure. This oxygen is more electronegative, therefore the partial negative charge. This hydrogen is partial positive charge. This hydrogen is partial positive charge. This oxygen is having two bond pairs, that one bond is with the hydrogen, another bond is with the hydrogen, and two lone pairs are also there. Because of these two lone pairs, water molecule is existing as a bent shape. The shape of the water molecule is bent and it is highly polar. Because of this bent shape and the polarity, it can have the intermolecular hydrogen bonds. It can have the water molecule can have the intermolecular hydrogen bonding, and the hydrogen bonding. One water molecule here can have the hydrogen bonding with the four other water molecules. Here, this red color is oxygen and this is hydrogen. This hydrogen is having an interaction with the oxygen of the neighboring water molecule, and here this oxygen is having an interaction with the neighboring hydrogen molecule, then this oxygen atom can have the interaction with the neighboring hydrogen atom of the water molecule. Then this hydrogen is having an interaction with the neighboring water molecule. Therefore, one water molecule can have an interaction with the four neighboring water molecule. This is the intermolecular hydrogen bonding. And because of all this polarity and the intermolecular hydrogen bonding, water is behaving unusually. Let us see what are the important behaviors of water. The first is water is an exceptionally a good solvent. Water is an exceptionally a good solvent. We know that for all we use water as a solvent. This is because of the hydrogen bonding and polarity. Let us see what are the important points or why we use water as a good solvent. The first point is that because of its polarity, the polarity of the water molecule, we know that there is a charge separation. Because of the charge separation, this water molecule is highly polar, and because of this polarity, water can have the interaction with the other polar molecules and ions. If other polar molecules or ions are coming, it can have the interaction because water is a highly polar molecule. The second point why the water is a good solvent is that because of the hydrogen bonding. Because of the hydrogen bonding. That is, as I said, the water is having partial positive charge. There is a charge separation, or water is a highly polar molecule. Because of this polarity or the presence of the highly electronegative oxygen atom, it can have the biological molecules like DNA and proteins can be dissolved in water. The DNA or proteins can be dissolved in water because of the presence of the highly electronegative atom of oxygen. And water also dissolves many polar non-ionic substances such as ethanol and glucose by forming hydrogen bonds with this ethanol and glucose. So it can have an interaction with the biological. This water is having an interaction with the biological molecules like proteins and DNA because of the presence of the oxygen in water molecule. And water also can have the interaction with the non-ionic substances, polar non-ionic substances like ethanol and glucose molecules. Therefore, it can also dissolve by forming hydrogen bonds with them. The next reason why the water is used as a good solvent is that the dissociation of ionic compounds. Because of the high polarity, it can break or weaken the electrostatic forces which holds the ionic compounds. Therefore, the dissociation of the ions will happen. Therefore, water is used as a good solvent. Because of the polarity of water, it can weaken the electrostatic forces which holds the ionic compounds. Therefore, the dissociation of ions happen. Next reason is that the small size of the water molecule. Because of the small size of the water molecule, it can effectively surround the solute particles. Because this water molecule is very small, because of the small size, the solute particles can surround the water molecules very effectively and they can disperse in solution. They can disperse in water. The next reason is that high dielectric constant. Water has a high dielectric constant which reduces the attraction between the oppositively charged ions in a solution, which further promote the dissolution. Since the water is having high dielectric constant which reduces the attraction between the oppositively charged ions, therefore promoting the dissolution. Because of all these reasons, water is used as a good solvent. This is the first property of water, that is, water is an exceptionally good solvent. Because of the polarity, small size, hydrogen bonding and high dielectric constant, we use water as a good solvent for many of the reactions or to dissolve any biological molecules, non-ionic polar non-ionic substances, polar molecules, etc. Now let us see the second property of water, that is, water has high specific heat and heat of vaporization. Water has high specific heat and heat of vaporization. Before we understand why water has high specific heat and high heat of vaporization, we have to understand what is specific heat capacity. The specific heat capacity is the property that indicates the amount of the heat required to raise the temperature of 1 gram of the substance by 1 degree Celsius. That is the amount of the heat required to raise the temperature of 1 gram of the substance by 1 degree Celsius. Because of the hydrogen bonding in water, it is very difficult to raise the temperature by the heat. The heat applying is used to break the hydrogen bonding. Therefore, the specific heat capacity of water molecule is high. That is written here. The extensive association that it shows through hydrogen bonding gives water an exceptionally high specific heat capacity, higher than almost any other liquid, because the added heat gets utilized to break the hydrogen bonds instead of increasing the temperature. Because of that, water has high specific heat capacity. Next thing is heat of vaporization. Heat of vaporization refers to the amount of heat required to convert 1 gram of a liquid into vapor without a change in temperature. The amount of heat required to convert 1 gram of liquid to vapor without a change in temperature. That is the heat of vaporization. Because of the hydrogen bonding, here the heat of vaporization also very high in the case of water. So this is about the second property, that is high specific heat capacity and high heat of vaporization. Both are due to the hydrogen bonding of water molecule. The third property is that water shows high surface tension and high capillarity. Water shows high surface tension and high capillarity. This high surface tension and high capillarity is due to the intermolecular hydrogen bonding present in water molecules. And this high capillarity and surface tension is used, which enables the absorption of water molecules by the plant roots by the capillary action when there is a dry period. So when there is a dry period, the water is utilizing the ground level water by the capillary action. This is the third property, that is water shows high surface tension and high capillarity. Next, we have the fourth point, that is water has the highest boiling point and melting point among the hydrates of group 16 elements. When we look into the hydrates of group 16 elements, that is oxygen, sulfur, selenium and tellurium, the hydrates of, when we compare these hydrates, the water molecule is having has the highest boiling point compared to the hydrates of the group 16 because of the intermolecular hydrogen bonding. We have already discussed that. Then next property is ice has a lower density than liquid water. Ice has a lower density than liquid water. So because of the intermolecular hydrogen bonding, each water molecule is connected to the 4 other water molecules tetrahedrally. Then when it forms ice, what will happen? This tetrahedral pattern will be changed to a hexagonal 3-dimensional structure. Hexagonal 3-dimensional structure. When it forms a hexagonal 3-dimensional structure, what will happen? There will be cavities and voids. So when there will be a large volumes or cavities, what will happen? We know that density is nothing but mass by volume. So if volume is high, the density automatically will be less. Because of that, ice floats on water. So the lower density, ice has a lower density than water is the property of water. The reason is that when the water exists as a water, the structure is tetrahedral structure. When water exists as a ice, that is a 3-dimensional structure where it has so many cavities and voids. Because of this, so many cavities and oils, the oleum is high. Since the oleum is high, density will be less. Because of that, ice floats on water. Another property is water shows anomalous variation of density between 0 degrees Celsius and 4 degrees Celsius. As the temperature increases from 0 degrees Celsius to 4 degrees Celsius, the volume of water decreases. When the temperature increases from 0 degrees Celsius to 4 degrees Celsius, the volume of water decreases. Since the volume of water decreases, what will happen? The density will increase. That is, density is equal to mass by volume. When the temperature changes from 0 to 4 degrees Celsius, the volume of water decreases. Since the volume of water decreases, this value is less, then automatically the density of water increases. If density changes or the temperature changes from 4 degrees Celsius to 0 degrees Celsius, what will happen? The volume increases. When the temperature changes from 4 degrees Celsius to 0 degrees Celsius, this volume will increase. When volume increases, the density will decrease. This density will decrease. So, it shows anomalous behavior when the temperature changes from 0 to 4 degrees Celsius. The density of the water will be maximum at 4 degrees Celsius, and the density decreases when the temperature changes from 4 degrees Celsius to 0 degree Celsius. So, these are the unusual properties of water. We have 6 properties. They are, the first one is water is an exceptionally a good solvent. Then the second one is water is having high specific heat and heat of vaporization. Third one is water shows highest boiling point compared to the group 16 hydrides. Then water has a high surface tension and high capillarity. Fifth one is ice has a lower density than liquid water, and the sixth property is water shows anomalous variation of density between 0 to 4 degrees Celsius. These are the properties of water. All these properties are due to the hydrogen bonding which exists between the water molecules. So, in this module, we saw that what is hydrogen bonding and the different types of hydrogen bonding. They are intermolecular hydrogen bonding and intramolecular hydrogen bonding. And finally, we saw that the 6 properties of water molecule because of the hydrogen bonding which exists in water molecules. Thank you.